Hello, this lesson is going to be a revision lesson on everything we've done so far on representing data, and there's a lot to have covered in this unit. We've got an end of unit checkpoint coming up, so we want to make sure you're as well prepared for that as we can. So we're going to have a look through all the topics we've covered, which are units of data: bit, byte, kilobyte, megabyte, gigabyte, terabyte. They were representing numbers using binary, representing text using ASCII, representing images using bitmap, and representing sound using sampling. We'll look at a couple of revision techniques you can use, and hopefully by next week you'll be prepared to do the end of unit test. So first of all, I'm going to do a recap of all the stuff we've covered. Remember, this is just a recap. This isn't enough to learn it from scratch. If you look at the recap and don't understand what I'm talking about, it's best you go back to that lesson on the VLE, watch that video again, or look at that PowerPoint again, do that quiz again, help yourself understand it that way. There's a lot more detail in the original lesson. This is just a recap to remind you what we looked at. This isn't me trying to teach it you the first time round. So first of all, our first lesson was on units. So you need to know that a single 1 or 0 is called a bit, that 8 bits grouped together is called a byte, and remembering that bits convert to byte by having 8 of them is a part that we struggle with. 1,000 bytes is a kilobyte, 1,000 kilobytes is a megabyte, 1,000 megabytes is a gigabyte, and 1,000 gigabytes is a terabyte. We've just got to remember those in the right order. Whatever method you need to, and we'll look at some methods later, that's what you need to do. We then need to do things like converting between them. So in this case, if you've got a number of bits and we need to give the answer in, say, megabytes, we need to divide by 8 to get the number of bytes. That's the step that most people forget. If you've got bits and you want bytes, divide by 8. Then divide by 1,000 to get kilobytes, divide by 1,000 again to get megabytes. If you needed gigabytes, you divide by 1,000 again. If you did terabytes, you divide by 1,000 again. So most of it is just dividing by thousands, but remember to divide by 8 first to get the number of bytes. So an example in this one, if you've got 1,176 million bits, you divide by 8 to get 147 million, divide by 1,000 to get 147,000, divide by 1,000 again, 147 megabytes. Lesson 2 was about binary, how we represent numbers using binary. There were 2 parts to that. First of all, we had to understand the counting system. So it's a counting system that just uses 1s and 0s, as opposed to our denary counting system that uses 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we always counted by having a look at the leftmost column, sorry, the rightmost column, and see if we could increase it. So if we look at that very first one, 0, 0, 0, 0, the rightmost column is a 0. We can increase that to a 1, so our next number is 0, 0, 0, 1. If we want to increase that, that rightmost number is a 1. We can't increase that. There is no 2 in binary, so we reset it to 0. We go to the next column, which is a 0. We try and increase that. We can. So it's 0, 0, 1, 0, etc. If you're still not sure about that one, go back to lesson 2 and look at the video there. There's a lot more detailed explanation of what that's about. If that is fine, then let's carry on. We also need to be able to convert between binary and denary, our counting system, by adding up the column values. So this number here, 0, 1, 0, 1, 1, 0, 0, 0, we put in the column values. We start at the rightmost column with a 1 and double each time. So 1, 2, 4, 8, 16, 32, 64, 128. Now everywhere there's a 1, which is the 64, 16 and 8, we add them together. 64 plus 16 plus 8 is 88. So 0, 1, 0, 1, 0, 1, 0, 0, 0 is the binary for 88. Again, a lot more detail on this in the original lesson if you need to recap it. We also need to be able to convert back, be given the binary and convert back to denary. Now I'm not going through this in detail because that's covered in the original lesson. There are 2 methods of doing it, but ultimately the main method is you have to try and make the number out of the column values. So if we want to find the binary for 25, we have to establish that that is made up of 16, 8 and 1. So therefore we stick 1s under 16, 8 and 1, and that's our binary. There was another method where you repeatedly divide by 2 and take the remainder, but I'm not going through that again now. You need to go back to the original lesson if you want to see that again. Lesson 3 was representing text. This was really straightforward because every character, so digits, letters, symbols, any of those things, are assigned a number. Then that number is stored as binary. And that's it. That's how we represent text. Ultimately, we need to know there is an ASCII table. That's one of the standards of storing text. That's a 7 bits per character, so 128 different characters can be stored using ASCII. There is an extended ASCII table which has 256 different characters because it uses 8 bits per character, and the ASCII table looks like that. You don't need to know it, you don't need to memorize it, but there's an example of the ASCII table. So if we wanted to store the word Bob with capital B, lowercase o, lowercase b, then we'd look up capital B, which is 66, would look up lowercase o, which is 111, and would look up lowercase b, which is 98. Convert 66, 111, 98 to binary. So that down there is the binary for the word Bob. Lesson 4 was representing images. Images were a little more complicated than text. We had to take an image and split it up into pixels. By making a smaller and smaller grid with smaller and smaller pixels, we get closer and closer to the original image. That one over there on the left is a very low resolution image. You can barely make out it's a dog. We add more pixels, more pixels, more pixels. By the time we get to this one, it's very clear what the image is. Each of those pixels is a single coloured block, and having enough of them makes us able to recreate the original picture. The number of pixels there are, the higher the resolution. The resolution means number of pixels per unit of area. So this is a high resolution image, that's a low resolution image, and you can see the difference. The disadvantage of high resolution images is that they take more space and more memory and more time to transmit. Each of those colours that needs to be stored for each pixel can be stored using RGB, red, green and blue, because when you're mixing light, red, green and blue light can be mixed to make any colour. So for example on this one, that orangey colour is made up, as you can see here, from having full red 255, half green 127 and 0 blue, and that mixes to make that colour. So the binary for it would be that. 255 in binary, 127 in binary, 0 in binary. Lesson 5 was representing audio. For this, we need to know that every sound can be represented using a waveform. A waveform is a measure of the air compression against time. And then to store each of those waveforms, we need to sample it. So at regular intervals, we measure the amplitude, the height of the waveform, and we store that number. Each of those measurements, we store those numbers as binary. The more samples that we take, the better the audio quality. So the one over there on the left has relatively few samples, and we end up with a very rough outline of the sound. This one here is supposed to be the same waveform, but it's got more samples, so we end up with a more detailed waveform and therefore a better reproduction of the original sound. Okay, so now we're going to have a look at some revision techniques. If you're perfectly happy with the stuff I've just talked about, you just need time to remember it, these techniques will help with that. However, if any part of the stuff I've just talked about you're unsure about, or you don't remember doing, or you're really stuck with, go back to the original lesson, have a look at that. I go through in much more detail in the original lesson. So, some revision techniques. All of these techniques we can look at, you can do it with pen and paper, because some people really prefer that, or you can use an online tool such as GoConquer.com to do it that way. That's entirely up to you. The first revision technique, and one of my favourites, is a mind map. Mind maps feel awkward to make initially, but they're a very useful process, and it's a process of making them that actually does most good. A mind map stores data in the same way that our brains do. Our brains take categories and they subdivide into other categories and subdivide that. So if I'm trying to remember gigabits, for example, gigabytes, what that means, I remember, oh, it's a representing data topic, and that helps me remember units, which helps me remember the various units, and I get to that one. So this is a trail showing that particular path through your neurons. That's why it's called a mind map. So these are really good at helping you remember categories of things and helping you work your way through those categories to get to the data that you need. This is an example one. I've started it off. It's not complete. Terabytes aren't in there. I certainly haven't done anything about converting binary. Haven't done anything for images and sound, but that's how you can get started with that. And the more you can add on to each of these, and if you use pictures to help you remember it, it really will help it stick. So if you're not sure what else to do in terms of revision, start by making a mind map of the whole topic. You can start out with this one and you can add to it and complete the sections I haven't completed. Revision technique 2 is flashcards. These ones are generally quite popular. A lot of people like doing these, and they can be very useful, but they're limited. They're very useful for helping you remember definitions and remember facts. They're not very good for helping you with techniques and understanding, but they're very good at helping you remember definitions. So what you do is you take a piece of paper, cut it into small chunks, or use an online equivalent, and on one side you write either a keyword or a definition or a question. On the other side you write the keyword's definition or the keyword, depending on which one you did on the first side, on the answer to the question. Then, once you've got a stack of these, to do your revision, you pick it up, you read the front side, and you say out loud what should be on the back side. You then check. If you got it right, you put it in one pile. If you got it wrong, you put it in another pile. You work through all of them like that. The pile you got right, you take to one side, and you take the other pile with you. You do some work on that. And then the next day, you take that smaller pile and you do the same trick. Read one side, check if you knew what was on the other side. If you did, put it on one pile. If you didn't, on another one. And this pile will get smaller and smaller and smaller until eventually you've got it all. It's a really good way to figure out what you still need to work on. So GoConquer has a nice online version of this where you set them all up and it presents them and flips them over for you, or you can do it pen and paper with real flashcards. Technique 3 is to make yourself a quiz. If you're writing questions and putting the correct answers in there, that helps you think about the data in a different way. It also helps you consider what kind of questions might come up in the end of unit test, which is a good way to think about it. So make yourself a quiz, either pen and paper or with an online tool. It's really good if you can swap it with somebody else, do their quiz, they do yours, and then you mark each other's. That's a really good way to make sure you understand it and you can see what misconceptions other people have, which can help you understand the topic a lot more. So those are the main revision techniques I'd suggest. Then for you to establish what you know, I've provided you with this. Now this is a very big quiz and it's not being marked or assessed or counting towards anything. It's for your benefit. The quiz on the VLE for this lesson is no new questions, but it's every question from the previous 5 quizzes, all put together. And what I would suggest you do is have a go at doing them all without using any notes or any revision resources or any extra help, and see what you already know. It will immediately give you option to review it, tell you what the right answers were. Again, this isn't an assessment, it's for your benefit. So you can look through and go, oh, I got that wrong, I got that wrong. I've totally nailed this. This I'm not sure about. Once you know that, you know where to focus your rest of your revision. So that quiz is there. You can make as many attempts at that as you like. Every time you do it, it will show you what you got right, what you got wrong, and what the right answers were. It's there for your benefit. It's not just a task. Don't just do it and say, there, I've done the task. I'm not even checking if this is done. This is for your benefit. It's for you to find out what you do and don't know, help you with revision. Okay, so that's all there is for the revision. You've got, obviously, this week to do it. You've got over half term to revise as well. And then at the start of next term, we'll do an end of unit test on this topic before we move on to the next one. Best of luck with that.